And please welcome our presenter, Jared.
This presentation, hopefully this is the one you were intending to come to, Ingredients for Predicting Student Persistence, presented by me, Jared Scolaro, as well as Phil Arcuria, who should hopefully be joining in a few minutes. So the kind of questions we're going to be addressing in this presentation. First of all, starting with the intro, what's actionable analytics? What's up with our predictive models? What are these? How do we select, derive, and implement predictors into our models? And then what predictors have we actually chosen to implement in our predictive models? And of these predictors, which are the most influential? So if you were at Hamid's presentation earlier today, he kind of did a big overview of our whole pipeline and process of our predictive models. This will be kind of zooming in a little bit closer on the actual model itself and what predictors we use and how we kind of select those. So first of all, just a very brief intro into actionable analytics. If you're not familiar, this is our charter. The mission of actionable analytics is to develop, deploy, and maintain innovative enterprise-level applications and solutions that provide data and actionable insights in support of programs, services, and initiatives aimed at enabling the success of all ASU campus immersion and digital immersion degree-seeking students. So in short, we as a team try to develop applications and solutions to help students be successful, and we use data to do that. And there are a lot of different aspects or components of actionable analytics, and Phil talked about those more in his presentation on the first day. But in this presentation, we're just going to focus on the predictive model, which is just one thing that actionable analytics does. So the predictive model is trying to predict next term persistence. And we use the word persistence to refer to, do students graduate or re-enroll by census of the next term? And so we have models that predict, if you're enrolled in fall, will you still be enrolled in spring? Or if you're enrolled in spring, will you persist to the next fall? And so, again, like I had mentioned, we're trying to predict next term census. That's when we determine if a student is enrolled for the next semester, if they're still enrolled at census. We break our student populations into distinct segments because many of predictors are only relevant for certain student populations, or maybe have a different impact in different subpopulations. So for example, online and immersion students, or you might have international students and continuing students, transfer students, first year students. We kind of break these segments up and use a similar approach, but a kind of different predictors for each of these segments. Many of them overlap. We include almost all undergrad degree-seeking students on online and campus immersion. We update our predictions daily. So each day, a student will have a new prediction, and based on, if any of their predictors' values have changed. And then we're continuously reviewing and enhancing our predictors and our models and our approach to modeling to try and improve their interpretability, their accuracy, and their, usefulness to our stakeholders. So just a very quick idea of our kind of process of how the predictions come about. So we have this pipeline that Hamid went into a lot more detail on it. We extract and enhance data for our model inputs. We do quality assurance. And then all this goes together to have a student's probability of persisting. So each student gets that value of persisting. And then so what we do from there is we give the students a quantile. Quantile just meaning we kind of rank them in categories, like, are you in the bottom 10% of predictions, the top 10%, or somewhere in between in a different, currently we're using deciles. We're looking at maybe if that's the best approach or not. And then from that quantile, we assign them to an outlook category. You might say, oh, the top categories are very high likelihood of persisting. And then we have high, moderate, low, very low. And that's another thing too that we're considering, is that the best way to group these for the way that they're going to be used by stakeholders. And so that's something we're continuing to evaluate. And then we also come up with is what are the top features that are most influencing each individual student's predictions? And a lot of this information is stored in various tables in the data warehouse. So then there's this question here is, where do these features come from? I'll put it like this. How do we select features, which is kind of a word I'm using interchangeably with predictors, to include in the model? And how does a feature go from just an idea that someone has? Hey, I think we should throw, let's use GPA. How does it go from an idea someone has, which that is what we use, to actually being in the models and influencing predictions? So there is a little process it goes through. First, we got to select features we want to consider. So there's a number of places that comes from. Institutional experience is a big one, especially at first when we just wanted to get something up and rolling and we had a timeline. We relied heavily on institutional experience. And thankfully, we were able to produce a pretty good model from that. We also look at institutional priorities. Are there things that leadership, what are their needs or how the model is going to be used, or things that they think should be in the model? Research and literature, a lot of people are trying to do predictive models that are predicting similar things such as graduation and re-enrollment. And so there are other ideas out there that people have tried that are helpful for our own models. Sometimes just intuitive reasoning. You might think, hey, this is an idea that I have that seems like it would make sense, so that could be worth exploring. There could also be weaknesses in our model. We might say, hey, our international students, we have a lot of financial predictors that maybe don't apply to them. So maybe we need to think of some other predictors specifically that would help improve our model for that population, for example, or any way we see our models underperforming for certain areas, we might try to look at predictors that could address that. The ease of derivability also is going to help us prioritize things. Some things are very easy and straightforward to get pull them right out of the data warehouse. They're already calculated for us, like maybe transfer credits. Other things could be harder to figure out where they're stored, what's the best way to calculate them. And so given two predictors, if one's really easy to derive and the others is really hard to derive, we may choose to look at the easier ones first. And then actionability just refers to, is this something that, is this predictor something that's actually going to be able to encourage a change in behavior? If we say, our prediction is based on someone's, their high school GPA was low. Well, that could be good in informing our model, but it's not very actionable. You can't tell a student, hey, you need to increase your high school GPA. So we do want to have predictors that are going to help our model, but also some that are actually going to be things that someone could act on. And then we do exploratory analysis. Sometimes as we're analyzing our predictors, we might see something interesting or it's something that catches our eye that sparks other ideas of what might be a good predictor. And so these are the main sources of how we kind of come up with ideas. Anytime we're kind of exploring a feature that we may want to include in our model, we try to document it very well. So this is one of our documents here. It just keeps track of, we call it data elements, all the predictors in our model. It keeps track of which segments of students. I mentioned earlier how we kind of have subpopulations that we model. Which segments is that feature used in? We keep track of what is the definition or description. What values can it take? Is it binary or continuous or something else, categorical? What's the logic we use? What tables do we use in the warehouse? Who are subject matter experts that we could talk to and ask questions about? Specifically, someone who's really familiar with the source tables. And then just any notes or other details. We try to keep track of this here, and I guess all the steps of our process, that down the road, hopefully it's very transparent and accessible of what we did and why we did it and how it could be replicated or built upon in the future. So Now to actually implement the feature, so like I said, if we're trying to derive the feature now, we've come up with an idea, we've kind of documented it, and we want to move forward with exploring it. We're going to get input from subject matter experts about what's the best source for it, what logic will work. We'll use SQL query or Alteryx to extract that data and validate to make sure that is the data that we think it is. And then we do exploratory data analysis. So that involves univariate analysis and bivariate analysis, which I'll go into just a little bit more detail in a few slides. And then eventually we get to this decision. Does this seem like promising that we should continue to explore as part of our whole model and look at in the greater context? Or maybe we reject it and say, this doesn't seem like it's really it's very predictive and something that we would want to include. Okay, so next, what is the exploratory analysis that we do? So starting out, we do our initial checks. This is what I mentioned about univariate analysis. How frequent is the variable? If it's categorical, or how many null values are there? What are kind of summary stats of mean or median or variance? What's on a weekly level? Because a lot of these can change over time. What's the frequency or distribution of this predictor? And then I mentioned we do bivariate analysis. So we compare it with persistence. Each week, what's its relationship with persistence look like? How does that change over time? And I'm going to be showing some examples from this particular semester in a few slides. We also would use logistic regression models currently to look at, is it a statistically significant predictor of persistence? Is that on a term level and also on a weekly level? And we're also considering looking at a tree-based models of doing this as well, because we do use a tree-based approach for our final model. We look at the relationship with other predictors. Is there a risk of multicollinearity? Is there a high correlation? Sometimes we might have a predictor that seems like a really good predictor, but when we include it with something else, it's kind of redundant, or we don't need both of them. And then multivariate analysis, and this is something that my colleague Hamid does more so, which is where he uses nonlinear multivariate feature selection to kind of compare, again, in the context of the whole model, is this a valuable addition? And then finally, again, any features we want to include in here, we have to think about it. It's not just numbers and data here. There's a very real life context that this fits in, of a university, and these are going to be used to hopefully make data informed decisions. And so we want to be cognizant of that and sometimes decide maybe there is a predictor that's very good at predicting, but for our context, it shouldn't be included in the model, or vice versa. Maybe there's a weaker predictor, but it really should fit in our model because of the context. Okay, so just some examples. I'm just going to go over a couple of quick examples of what the exploratory data analysis might look like. Just two predictors that we looked at. So one of them was current term withdrawal rate. And so we were looking at, could this be a potential predictor in our model? And this refers to the proportion of a student's enrolled credits from which they've withdrawn in the current term. So this is saying after the drop deadline, how many courses were enrolled in, and then how many did you end up withdrawing from? That's what this proportion refers to. And I'm just going to give you a couple snippets. I'm not going to go through the whole analysis here, but I looked at the distribution of this. And so this is two visualizations to kind of show it. You might be more familiar with a histogram, seeing that most students don't enroll or don't withdraw from a large proportion of their classes. This is called an empirical cumulative distribution function. And it kind of shows you for each value of the predictor, what is the percentile of that value? So we see right here, 81% of students withdrew from 0 courses in this term. And then if we look over here at around 33%, that is the 90th percentile. So 90% of students withdrew from fewer than 33% of their courses. So that's kind of one way we can see the distribution of this predictor. One of the things I did, so again, we're trying to look at this in the context of how does it relate to persistence. So one thing I did is I just used a decision tree to kind of look at it in bins and see if this, as we increase in value for this predictor, does the persistence rate change? So again, I use a decision tree to kind of try and bin this up. And so we see here, this represents students who withdrew from a quarter of their courses or fewer, and the persistence rate is about 85%. Here we see students who withdrew from 1/4 to half of their classes, the persistence rate now is in the low 70s. And then students who withdrew from at least half of their courses, their persistence rate was only 49%. So it seems like there's a strong trend here. And then this final one, the null values represent students who actually were not enrolled in classes anymore after the drop deadline. We can't calculate the percent they withdrew from because they had no classes still enrolled by that time. And in this case, those students, 28% of them persisted to the next semester. So it seems from this analysis, okay, as persistence or as the withdrawal rate increases, the more courses you withdraw from, the lower your persistence that would be associated with. But then just out of curiosity, I bin this into 10 bins now instead of just into 4 bins. I did it by 10%. Did you withdraw from up to 10%, up to 20%, up to 30% of your courses and so on? And here I actually saw that up to 30%, there's not really a strong drop in the withdrawal rates. I mean, in the persistence rates, it's actually kind of consistent. So students who withdraw from 1/3 of their classes or fewer, that's not really a bad sign. But just as it begins to increase after that, then we see more of a decline in the persistence rates. And then I showed this to someone, they noticed this weird decline here. In this category, which is 50 to 60%, it's actually just the way that fractions work out. It's unlikely for a fraction to fall in this category compared to other ones. There are very few students in this category, so that kind of explains the dip there. Is it's just because there's low frequency who fall in this bin. So that was just one interesting finding from our exploratory analysis. So, if you withdraw from just a 1 or 2 courses, it may not really be a negative indicator. Another one we looked at that I thought was interesting was low MyASU usage. So this predictor indicates if an individual's MyASU usage is less than or equal to 30% below average activity of all students in their academic level. Academic level referring to first year, sophomore, junior, senior. And we borrowed this definition from the historic retention dashboard. And so when we looked at this, we looked each week, what is the persistence rate of students who did have the indicator in orange and did not in blue? And so again, this axis shows the persistence rates. We see the week of the semester on the x-axis. And so we see, for example, if I look at week 12 here, so the orange line, students who did have low MyASU usage in week 12, their persistence rate was a little bit above 70%, but those who did not have low MyASU usage, their persistence rate was closer to 90%. So that shows us that early in the semester, it appears that there wasn't a big difference. And then later in the semester, the difference appears to grow. So it seems like having low MyASU usage later in the semester is more predictive. However, again, we talked about in our model, we break it up into segments. When we looked at this segment based on it for online segments, when we looked at this predictor, this weird pattern came up where it kind of flip-flopped when it was predictive, and if it was a good or bad predictor. It appeared like early in the semester you do want to have low MyASU usage, later you don't, and that seemed kind of weird and unusual. So we actually modified our definition of this and kind of explored, what if we kind of compare students against the average MyASU usage of their modality rather than academic level. So compare online students against online students and immersion students against immersion students. And all of a sudden, in all of our segments, the difference increased in the it was the I guess the predictive power increased to where there was a much clearer distinction in the persistence rates among students who did or didn't have this indicator. And we even saw in our online segments, I just picked one of them, but this was true for all of them, that weird flip-floppy pattern goes away and it's a much more consistent predictor. So that's kind of part of why our exploratory data analysis is important, is sometimes it will inform or adjust how we're defining what our predictors are that we might want to consider for our model. So again, just comparing students against the average in their modality rather than academic level was more predictive in every segment. And then we're going to probably explore more alternative groupings. Maybe modality is good, but there could be another one that might be better. So again, always continually trying to refine and improve and re-examine our process. So now after all this process happens for all these predictors, what actually has made it into our predictive model? So here's all the ones that we had in fall 2021. We have certain ones that are, I said, usually static because they tend not to change. Some of them could change during the semester, but in general, they remain constant. And then some of them are dynamic, meaning they could change daily or frequently during the semester. And then the asterisk refers to the new features that were implemented in our fall 2021 model. And again, these slides will go out afterwards, so I'm not going to read through all of these, but I am going to look at, we went to look at how do we kind of examine which of these features are the best or the most contributing to the predictions that we're putting out there or we're producing. And so this is again something that Hamid mentioned in his presentation when he did the overview, was the SHAP values. He went a little more in depth of this definition, but just a brief definition of what this means is it's the weighted average of the marginal contributions of each predictor across all permutations of the complete set of predictors. And I would say, if you don't want to think about it too technically, just think, okay, SHAP value represents the marginal contribution of each predictor. And the way it's calculated, again, I would say go review Hamid's presentation from earlier when the recording comes out, or look at his slides. But one of the benefits of SHAP values is they're globally interpretable. So they can show how much each predictor contributes to the target variable. And they're also locally interpretable, which means each individual observation gets its own SHAP value. It can tell you how much each predictor contributes to the overall model and also to each individual observation. Also, a big benefit is it works for tree-based models, which sometimes can be a little bit less interpretable than linear models or linear regression models. So that's a great benefit that we get from it, is we really do want to have interpretable results so that they can be actionable. And so that's why using the SHAP values to kind of pull out that interpretability is really helpful. And again, just to comment as always, right, SHAP does not identify causality, but we can still, it still tells us which features are more predictive than others. So this is an example of a type of chart that Hamid also showed in his presentation. But what it does is it kind of shows on an individual level. This is a random individual student. It shows which predictors are impacting that individual student's predictive score. So they start out with kind of a base average prediction rate for their segment right here. So this is two separate visualizations of the same idea. Right here, it's shown as the base value. And right here, it's shown as this gray line. And then there are certain positive contributors up here. So you could think of them as they kind of push that prediction up from the base rate. And then you have negative contributors shown in blue, which kind of push that prediction lower. And in this particular case, the negative contributors outweigh the positive ones. And so this prediction ends up being ending up as a lower prediction overall. And so this visualization is cool because the predictors are ranked by order of the absolute value of the SHAP value. So you have the least impactful ones down here at the bottom, and then more impactful ones towards the top of this visualization. And so you can really visualize what things are the most impacting this student's score, and why is their predicted persistence probability 0.31. Another way to visualize this is a waterfall graph. And again, so it's kind of showing the same thing here. You have the average prediction for the segment, and then you have some negative contributors, and you can see how much each of these contributors is affecting the probability. You can also see positive contributors, and then finally what their prediction ends up being after everything's accounted for. And so this is a visualization we are using internally, and that it would be, hopefully we will be able to think about the best way to possibly share some variation of this with maybe some stakeholders or frontline staff, depending. We would just have to take into account, which predictors it would be most helpful to show, and if there would be certain predictors that might not be helpful to be showing, depending on the context of how this would be used. So that's, I guess, something we always want to be keeping in mind is how is this going to be used, and what information is the most relevant to share, and what would be less relevant or less helpful. So then what we can do after that, if we have all these SHAP values for individual students, I can see for an individual student, how much do each of these predictors contribute? And then what we can look at is, and this is a dashboard. So the SHAP values, this was a lot of work from Hamid, who researched and implemented and created these graphs for the SHAP values. Also, my other coworkers, Sujata, has visualized these in a lot of very cool dashboards, where this particular one shows the mean absolute SHAP value for each predictor within a given segment. So now you can kind of generalize and see how much does each predictor contribute to the predictions overall in a segment. And so the absolute value, meaning for this visualization, negative and positive contributions we're really just looking at the magnitude of how much it contributes to predictions, not really if it's a positive or negative contributor. So in this case, in this segment, in this term, fall 20 to spring 21, the percent of cost of attendance met by gift aid tended to affect predictions the most out of all our predictors in campus immersion continuing resident segments. And so again, we can do this all for all of our segments. And so I'm going to show, oh yeah, and I just talked about this. The top predictors for this case were the percent of cost of attendance met by gift aid, credit hours, cost of attendance, total cumulative credits, relative Canvas performance. And we can look, we have this for each segment. We can see what are the top. So I just put here the top 5 predictors, and the colors are just to kind of distinguish one from the next. The color doesn't mean anything. I also excluded predictors that were directly related to next term performance because so we do later on in the semester, when students begin enrolling in the next semester, that's a very strong indicator. If someone's enrolled next term, they're probably going to still be enrolled next term. So those tend to be among the top predictors. So I just excluded those because I thought they would be less interesting than some of the other ones. And then, so this is for immersion segments. And again, the slides will go out here. I also looked at this for online segments. And so, so for example, for online first years, you got what percent of their costs are met by gift aid, how many credit hours are they enrolled in, what is their cost of attendance, their relative Canvas performance, meaning that one refers to on assignments, how are they scoring relative to their some of their peers in the same courses. Like it's kind of a Z-score. How close are you to average? Are you above average or below average for your performance? And then also this one happens to be how many times do you actually log in and are active in Canvas. So just as an overall summary here, the top predictors that as I looked through the complete lists for all these segments, the ones that kind of categories that stood out as the most as top predictors were credit hours enrolled or accumulated. That one's kind of, I think, the more full-time students tend to persist at higher rates. I think that's generally known. Cumulative GPA, students with higher GPAs tend to persist at higher rates. Gift aid, students who have greater percent of their cost of attendance covered by gift aid tend to persist at higher rates. Loans also can help students persist more as well. And then relative Canvas activity, students who perform poorly or who are less active than their peers tend to perform worse. I forgot to finish that sentence there. But yeah, so those were just some of the top predictors that we observed here. So that's, how are we doing with time here? I forget when this session ends.
It's ends at 11:15, Jared.
Great, perfect.
You got 7 minutes left.
Great, so we'll have time for questions. So I want to say thank you to particularly the Actionable Analytics. I say extended team because there's our direct team, but also other people who contributed. Jennifer Wilkin, Phil Arcuria, Lori Twist, Hamid, and Sujata, and Josh Johnson were big contributors for this. I also want to acknowledge the artwork was from Noun Project. These are the artists who did this. And then viewers like you. And we have time for questions. Thank you all for attending, by the way. Yeah, does anyone have any comments or questions?
I actually have a question, Jared. So how often do you go back and compare your predictions to the actual outcomes?
Yes, that's a great question. So especially every census, when we get to a new term, that's when we can really tell, did our predictions that we made for this term actually, did they pan out the way that we expected them to? So I think every semester we do that. I don't know, Phil, if I'm kind of forgetting or missing anything.
No, that's right. It's a good question, Kendall. So what we do is once we hit census, since that's what we're predicting, is we'll pull the actual observed, and we have another dashboard that Sujata on the team's developed that will look at the predictions versus the actual. So we look at it 2 times. We'll use the test set during training to see, all right, how well do we think the model's gonna do? And then we'll actually look at the observed once we hit census. And then hopefully there's not a huge deviation between those, but if there is, then we kind of dig in of, okay, why did we think we were going to do better in these areas than we actually did?
This is Lisa King. I have a question. I'm curious how much of your time in an initial project, and I know this kind of ends up being iterative, but when you started out, how much time do you spend on exploratory data analysis before you get started on the modeling and predictive analysis?
Phil, do you want to answer this one since you've been more involved since the conception of the model?
Sure. Yeah. So I'm a big believer in exploratory data analysis. I kind of think it's the foundation. So when we put together the team, that really the main focus of Jared's position is to do exploratory data analysis, at least in the context of the predictive modeling. There's other things he works on. So we devote quite a bit of time to it. Although one area that Jared's done a terrific job in is he's made things as programmatic as possible. So everything he's doing is in Python. So he's built Python scripts and classes. So if someone says, hey, what about this new variable? Our time to duration from ideation to getting to that first yes/no decision is dramatically reduced because he's built so many of those scripts where it's now focusing on how do we get the data and how do we define it. But after that, I don't want to say it's total plug and play, but it's getting pretty close with the way that Jared's put it together. Which is, I'll just throw out a plug there. If anybody has any variable they think, hey, I think this would be really great, let us know, and we're happy to investigate it. So, for example, now we're partnering with Mark McCann over in the library to look at some of the data that they're collecting there to see, hey, is that predictive? So that's an open offer to the community if there's anything of interest.
Thank you all for participating. Thank you very much for to the presenters. It was great. And thank you all, and have a great day.
And thanks, Kendall, for all your help in setting this up and for volunteering. I really appreciate it.
No problem. Thanks, Phil. Thanks, everyone.
Yeah.